All right, so video over stoichiometry and getting into uh, mole, or wait, back up. Getting into how to do a stoichiometry problem. So getting into applying what we've been learning about balancing a chemical reaction, finding molar mass, um, and then being able to use that information, right, using the ratio of a chemical reaction, for example, to figure out how many grams of a substance could either be produced or how much would be needed. And this is very useful, okay? Like, as in, if you're saying, why do I learn this in chemistry? Because anytime you want to produce something, you need to know how much to measure out. You need to know how much you're going to need of each substance to produce the amount you need of a particular product, okay? And if you're making anything, you work for a pharmacy company, right? You make like pharmacological sciences, like you're making prescription drugs, for example, right? You need to make sure you get the exact amounts so that your reactions produce the stuff you need in these specific amounts, so that when you make a drug, when you make a new food, when you make paint thinner, or whatever you're making, that you have the right stuff produced, and that involves amounts. Okay, hopefully you're saying, okay, I kind of get you. It matters. Okay, to do a Stoic problem, all we got to do is look at a problem, figure out the reaction, balance the reaction, get the molar masses, use the ratio in the reaction, and get to grams. Okay, so that's a basic Stoic problem. All right, and it can get more complicated. We could do limiting reagents, which is its own video. We could talk, if you want, about molarity and work with molarity as extra steps. I mean, there's many things you could do with this. Working with pressure of certain gases. I mean, you can do lots and lots and lots and lots of things with this. But this is I'm making this video for like a high school chemistry class, right? So, for right now, we're keeping it pretty easy. We will get into limiting reagents as we proceed. Okay, but that's not yet. Okay, that's even harder, believe it or not. So for now, I got to take this and I got to get a chemical reaction. So I got to read this and say it's iron. So iron is Fe. Whoops. Fe. And we're reacting this with, it says excess sulfur. Excess is a word right now that doesn't really mean much. It basically means I have enough sulfur. I'm going to have enough no matter what. Excess means like, hey, I have basically infinite. So however much iron I have, I will have enough sulfur. Okay, this is to prevent a limiting reagent problem. Okay, when you get to a limiting reagent problem, then it might not be excess anymore, or rather it won't be excess anymore. Okay, but for now we say, okay, it's iron plus sulfur, and it's going to make something for us. Okay, it's a synthesis reaction, so we're thinking about our charges. Now in this problem, it doesn't specify if it's iron 3 or iron 2, right? So in theory, right, if this question was just written like this and you picked iron 3 sulfide, is it wrong? No, but defaulting to iron 2 is probably more reasonable, okay? This problem, again, like if I gave this in a test, you gave this in a quiz, and you gave me iron 3 sulfide, I'm not going to be like, wrong. I'm going to be like, oh, okay, you picked iron 3 instead of iron 2, nothing wrong with that. Okay, that's a little bit harder to know why would it be iron 2 or iron 3, okay? So let's just go with iron 2 for now. So what is that going to look like? We have Fe plus 2, and we have sulfur minus 2. Okay, so we have these two charges. We're going to do our crisscross. We simplify it. What do we get? FeS. Okay, so for this problem to be pretty easy, we make it iron 2 sulfide. Okay, iron 3 sulfide would be a little bit harder, but that's okay. So we do this. We got to balance the reaction. We look at this reaction. It is balanced. That's why iron 2 sulfide is an easy one. Okay, so we're saying it's 1 iron, 1 sulfur. Hey, 1 iron, 1 sulfur. We are balanced. That's good. And now we need to do our molar masses. Okay, and I have a video about molar mass, which you can check out if you're not sure about that. For molar mass, I would do them somewhere else on the page. I would not do them right underneath it. I would do it somewhere on the side. We have what substances? We have iron, we have sulfur, and we have iron 2 sulfide. Those are my 3 substances, okay? And this is where your periodic table is going to be your best friend, okay? So for iron, I look at this, and it's about 56, but for a chemistry class, I'm going to hold you to the 1,000th place, generally speaking. So for the mass of iron, we're going to have 55 point, let's see, 845, sorry, 845 grams per mole. Okay, it's getting a little messy. Maybe I'll change the size of the marker a little bit. Maybe that's better. It's probably a little too small. 3 pixel. Let's do maybe, I don't know. Yeah, I don't know, 6 or so. Yeah, there we go. 5 should be good. Sulfur is going to be 32. Yeah, that's a lot better. 32.065, I believe. Am I right? Yeah, 0.65 grams per mole. Remember, molar mass is grams per mole. Okay, and then iron sulfide, I just got to add them together. Okay, so I'll use my calculator for that. So I got, 55.845 for the iron plus 32.065, and I get, in this case, molar mass of iron 2 sulfide is 87.91 grams per mole. Okay, so I need those 3. Okay, and now I can start the Stoich problem. So what I'm going to do, I'll change colors again, I guess. Green, I like green. We are starting with 12.25 grams of iron. So I'm going to put in my fence. Remember, I like the fence method a lot. 12.25 grams of iron. Okay. And I got to convert this to moles. Okay, this is why we do moles, or this is why we do molar mass. This is why we have moles in chemistry. It allows us to have a reaction. If it says that there are 5 atoms of this react with 4 atoms of this, right? That's a ratio of 5 to 4. But I can't count individual atoms, right? So we use moles. So if it's 5 moles of this to 4 moles of this, that's the ratio. But I need to get it in moles in the first place. Okay, so I need to convert it to moles. So molar mass of iron, we just found it. There is 1 mole of iron per 55.845 grams of iron. Right, we just got that from the molar mass. Okay, this is nice because grams of iron go bye-bye. So now we have moles. Once we have moles, then we can work with the chemical reaction, because then I can work with the ratio. Okay, so I have moles of iron right now, and I want to convert this to moles of iron 2 sulfide, right? So the ratio, we already balanced this, right? The ratio is 1 mole of the iron 2 sulfide per every mole of iron. The ratio happens to be 1 to 1. Okay, that's pretty nice, because that's basically doesn't change anything for us, right? Right? Mathematically, 1 over 1 is 1. What a surprise. But this, technically, what I've done is converting iron into iron sulfide. So now I have moles of iron sulfide. If that's all I wanted, if I just wanted moles of iron sulfide, I'd be done. But I want grams of iron sulfide. So I'm going to use the molar mass of iron sulfide, iron 2 sulfide to be exact, to find how many grams. Okay, so the molar mass we just found earlier is 87.91 grams of iron 2 sulfide per every mole of iron 2 sulfide. And again, this is where the fence method is very nice, because you're like, that cancels out moles of iron sulfide, and we have grams. Okay, we plug this into our calculator. Remember, never, 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 never cross multiply fractions, right? Don't do that, it's wrong. We multiply across. And we're going to get an answer of, let's see. And again, you should pause this and maybe do the calculation yourself to make sure you know what you're doing. Let's see, what do I get? I get 845, is that right? Yep. I get 19. Wow. Try this again here. 19 point, I'm going to round to the 1,000th place, so 19.284. If your class requires significant figures, you can follow sig figs here. Sig figs would require 4 significant figures. I'm putting 5 sig figs, but that's fine with me. Okay, sig figs really don't matter until you're researching in college, in my opinion. So somebody can right now yell at me and say, no, but it's pretty true. That many grams of iron 2 sulfide. Okay, that is one of my answers. You say 1. Well, technically I found the answer. But to prove a point to you, let's go ahead and find how many grams of sulfur we're going to need. Okay, because I have a sneaking suspicion the answer is going to be about 7. And maybe you're like, oh, I see what he's doing. But we'll see. So how do I find sulfur? Easy. I do the exact same calculation. I start out exactly the same. So I say 12.25 grams of iron. Start out with that. Oops, that's not what I wanted. Let's back up. Back up. I went too far slanted, didn't I? Let's do 12.25. Molar mass, same. 1 mole of iron is 55.845 grams of iron. Again, to cancel out the grams. Hooray. And now I want to go to sulfur. It happens to be 1 to 1, right? The ratio, again, happens to be 1 to 1. Easy reaction, very simple. The synthesis reaction is 1 to 1. So it's, again, 1 mole of sulfur per every 1 mole of iron, okay? And then I need the molar mass, right? Because that cancels out the moles of iron. We have moles of sulfur. I need grams of sulfur. So we're going to have our 32.065 grams of sulfur is a mole. That's the molar mass of sulfur. And again, that cancels out the moles of sulfur, left with grams of sulfur. How many? Well, let's see. Again, if I were you, I'd pause it, or I guess while I'm doing it, right? Go ahead and check what you get, because you want to make sure you can do this. Otherwise, it ain't that helpful, is it? And I get an answer of, hey, look at that. I said about 7, right? 7.0. Well, again, we're on to the 1,000th place, 034. 34 grams of sulfur. If you're saying, oh, you knew that because you did this earlier. No, I know that because I know the science behind this. AKA, we found grams of iron sulfide, right? How did we do it? We did this. We got an answer of 19.284 grams, right? That's the product side, right? That's this side of the reaction. There's only one thing, and it's 19.284. If this is balanced, there better be 19.284 grams on the other side, okay? So for iron, we had 12.25. How do we know that? We were given it, right? It's right there, 12.25 grams of iron, and we just calculated 7.034 grams of sulfur, okay? Now realize we've rounded these, okay? So when I add these together, I should get ideally exactly 19.284, okay? Because I rounded, I might have a slightly different answer. Instead of 19.284, maybe it's 19.285. Maybe it's 19.283, right? But it should be very close. And if you didn't round, if you kept the answer all the way out, then it would be exactly the same, okay? And that's important. So let's see if we're right. So take that 7.034, just to make sure, plus our 12.25, and what do we get? We get 19.284 exactly. Well, that's pretty nice, because that's exactly what I'm looking for, okay? And this is how this whole thing works, is the law of conservation of mass. I have this many grams on the reactant side, I better have that many grams on the product side. The trick, of course, is where those grams are, or rather, what molecules they're in, right? It used to be iron atoms, it used to be sulfur atoms. Now they're together, and they're together as this thing called iron 2 sulfide, right? But the amount of atoms, the grams total, is always going to be the same. The only kinds of reactions where this is not true would be like a nuclear reaction. Okay, nuclear reactions literally transform some of the matter into energy. Okay, that's why they're so powerful. That's why there's so much energy released. Okay, so like a fusion reaction literally releases energy as a form of matter, like matter is being converted into energy. A fission reaction, same thing. Okay, it's a very small amount of matter. You got to realize it's a very tiny amount. But when you're working with Einstein's equation, E equals mc squared, everyone's heard of E equals mc squared, right? 1 kilogram of mass is an insane amount of energy. Okay, but yeah, that's getting into something else. Okay, so don't panic about that. We're not doing that in chemistry. All right, at least not to that level. Okay. So anyway, hopefully this is making sense. And every Stoich problem is going to look just like this, except usually a little more complex, more stuff. This reaction only has 3 things, right? If I had a reaction that had 7 things, well, then I need to have 7 of these calculations, okay? But the underlying math you're doing is just what's shown in the fence method. It's really not that bad as long as you practice it. Okay? It has a reputation for being difficult. It has, oh my God, stoichiometry. It really isn't that bad as long as you practice and practice and practice. And then it'll start to click and you'll say, oh, this isn't so bad. Okay, so this video called quits here. I'll have some more videos probably going over some more complex ones, so some more practice problems, but hopefully this helped you out and hopefully you'll feel more comfortable with stoichiometry. Have a great rest of your day.